Hi, everybody. Now we're doing section 3.7, elasticity of demand. This is really a business application. This whole section is really, a giant business application section, elasticity of demand. So we have to do the concept of relative rates of change. We're going to start with that, and then we're going to get to elasticity of demand. So relative rates of change. Here we go. The relative rate of change of a function is f prime divided by f. So the derivative divided by the function itself, that's called the relative rate of change. Because f prime is, is the rate of change. F is the function itself. So you're comparing how the function changes, the rate of change compared to the function value itself. So that's relative rate of change. And the percentage rate of change, that's just going to be 100 times f prime over f, or it's 100 times the derivative of the ln of f of x, because the derivative of ln f of x, as you know, is f prime over f. We had discussed this already in the past, and that's relative rate of change. So let's do some math. Here we go. Blah 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 blah. Okay, so let's look at a problem here. So example 1, table 1 lists the GDP of that's gross domestic product expressed in billions of dollars of 2005 dollars. So it's billions of dollars of what a dollar was worth in 2005. Because as you know, the value of a dollar, fluctuates. And the U.S. population from 2000 to 12. So a model for the GDP is f of t equals 209.5 t plus 11,361. Where t is the number of years since 2000. So in 2005, t would equal 5. In this year, 2021, t would equal 21, and so forth. Find and graph the percentage rate of change, f of t, for t between 0 and 12. So what do you got here? So P of t is the percentage rate of change of f of t. So basically, all I got to do is P of t is 100 times the derivative of the ln of this sucker right here. Now, the derivative of the ln of a function, you put the function, anything that's inside the ln just goes down on the bottom of the fraction, and the derivative of the top goes on the derivative of the inner guy goes on top. The derivative is just 209.5, but it's 20,950. Why is that? Oh, why is that? Because it's 209.5 times 100, so it's 20,950. And the graph is right over here, and it's notice that P of t is decreasing even though the GDP is increasing. That's kind of cool. All right, and that's percentage rate of change. All righty, and let's go to elasticity of demand. So suppose let the price P and demand X for a product be related by the price demand equation of the form X equals F of P. And the elasticity of demand at price P, denoted by E of P, is E of P equals the relative rate of change of demand over the relative rate of change of price. And so to get the relative rate of change of demand, we do the derivative with respect to P of the ln of F of P. To find the relative rate of change of price, we just do the derivative with respect to P of ln P. So, and that's how you crunch it out. So the derivative of ln of f of p is f prime over f, and don't forget there's a negative sign there. Let's not forget that negative. And the derivative of ln is just 1 over p, and this becomes, if you just simplify this fraction a little bit, it becomes pf prime over f, negative pf prime over f, and that's how you crunch out the elasticity of demand at price P. And now, so here's our theorem. If price and demand are related by X equals F of P, whereas it's a function of price, then the elasticity of demand given by E of P is equal to, is given by E of P equals negative PF prime over F, which is what we just said a minute ago. So let's use this to do a problem now. Let's just see how, let's see this in action. So example 2. The price P and the demand X for a product are related by the price demand equation, which is, in this case, X plus 500P equals 10,000. So P is the price, X is the demand, which is the number of products that we made at a given price, and that's the story. Because the price will affect the demand. In sometimes in unexpected ways, but the price affects the demand. Obviously, if you overprice something, the demand is gonna go down because somebody wants to pay that much. But price and demand, have sometimes interesting relationship between them. Anyway, so we want to find E of 4, E of 16, and E of 10, and we want to really or more generally, we want to find the elasticity of demand, E of P, in general. So if X is equal to 10,000 minus 500P, I can factor out a 500. So X is equal to 500 times 20 minus P. And if X is a function of price, which is 500 times 20 minus P, P has to be between 0 and 20. Now, why does P have to be between 0 and 20? Well, because this has to be positive. The demand has to be positive. The demand is positive. It's got to be positive. 20 minus P has to be positive, so P has to be less than or equal to 20. Obviously, the price has to be greater than or equal to 0. I mean, it's either free or you're charging for it. You're not going to pay people to take it. Sometimes people do want to pay people to get rid of the cart away the junk, but that's different. Anyway, since X and P both represent non-negative quantities, we must restrict P so that 0 is between P and 20 because they're not negative, as I explained. Here's what the graph of it looks like. So E of P is going to be, using the formula we figured out before, is P times F prime over F. So that's P. F prime is just negative 500. Just to remind us what was F. F was 10,000 minus 500P. So F prime is just the negative 500, and then F itself is 500 times 20 minus P. The 500 is going to cancel. Now look at this. I had a negative here and I had a 20 minus. I went to the negative. Oh, so I have a negative here and I have a negative there. Those two negatives cancel. So I just have P over 20 minus P. And now to get A, B, and C, I just plug in the different numbers. Plug in the different values, I should say. And in order to interpret this, we have to remember the definition of elasticity. Relative rate of change of demand divided by relative rate of change of price, and negative that. So 20 over P over 20 minus P. So E of 4 is going to be 4 over 16. And which is 0.25, which is less than 1. So if the $4 price changes by 10%, then the demand will change by approximately 0.25 times 10%, which is 2.5%. So if the price changes by 10%, the demand changes by 2.5%. E of 16 is 16/4, which is 4. Now notice that's greater than 1. So if the $16 price changes by 10%, then the demand will change by 40%. And finally, E of 10 is equal to exactly 1. So if the $10 price changes by 10%, then the demand will also change by approximately 10%. And that's awesome. Awesome. Alrighty. So here we have a basic table that explains this, that if E of P is less than 1, it's inelastic. If E of P is greater than 1, it's elastic. And if E of P equals 1, then it's a unit. And these are the various interpretations and so forth. Now to I think let's go on to example 3. A manufacturer of sunglasses. I need new sunglasses, by the way, in case anyone was wondering. A manufacturer of sunglasses. I have my sunglasses. I just want to say I had my sunglasses for years. I mean, like 20 years. And then I got a new car, and in the switching back and forth, some of the sunglasses got lost. I'm just got to be somewhere, but I just can't find them. Anyway, the manufacturer. By the way, the sunglasses I have, they're not very dark. They're pretty light, so they allow the good light to come in, but they have all the UV protection, so all that stuff gets blocked out. So I love those sunglasses, and I had them for years, and now I can't find. They're Harley Davidson. Just want to say. Anyway, X is equal to F of P, which in this case is 9,500 minus 250P. If the current price is increased, will revenue increase or decrease? So again, E of P is equal to negative PF prime over F, which is negative 250, because it's just that coefficient right there, over 9,500 minus 250P, which I factor out a 250 from both sides, or cancel out 250 from top and bottom, and I get P over 38 minus P. So E of 15 is 15 over 23, which is 0.65, which some of the smarter people may know that 0.65 is less than 1. So at the $15 price level, demand is inelastic, and a price increase will increase revenue. That, my friends, is the story. That concludes this section. It's a very short section. Just really this whole section really was just an application section specifically geared for business. And I hope you all enjoyed it. Hope you had as wonderful a time as I did. And we'll see you guys next time. Bye, everybody. Bye.